This is the video for Mod 7 Lesson 2, Parallel Lines and Transversals. The goal of this video is we're going to be looking at angle relationships, but when we have parallel lines that are cut by a transversal. So the goal is going to be to identify angle relationships formed by parallel lines and transversals and apply those properties to solve for unknown values and unknown angles. The first page in notes has a whole bunch of vocabulary terms, and I'm going to mark these on the diagram that's at the bottom of the page, right? Just because they couldn't fit side by side. So the first term we're going to talk about is a transversal, and this a lot of times is a topic that maybe we've even seen in middle school. I don't know if you saw it in Math 1. And basically what happens is when we have parallel lines, which a lot of times are indicated with like these little arrows here. We know a few things already about parallel lines that we learned from Math 1. These are lines that don't intersect each other. If we were graphing them, they would have the same slope. When we talk about figures and geometric shapes, a lot of times they're constructed with parallel lines. So we want to make sure we know angle properties that can be formed when we're working with lines that are parallel. So the transversal is basically the line that intersects those parallel lines at two different places. And what it does is it creates these 8 different angles. It creates a set of angles that are essentially formed with one of the parallel lines, and then almost the same type of angle, like the same set of angles is repeated for the second parallel line. So we're going to notice a lot of similar measurements, and we're going to start naming those angle pairs and relationships. The first one we're going to talk about are called same side interior angles. And so a lot of the how we describe that is it's kind of in the name. So we're looking for angles that are on the interior. So these are angles that are inside or in the interior of a pair of parallel lines. So I'm going to go ahead and... So if these are our parallel lines, the interior angles are the angles that are inside of these parallel lines. So that would be angle 3, 4, 5, and 6. When it says same side, that means they're also on the same side of the transversal. So if this is our transversal, we're looking for angle pairs that are on the same side of the red line, but inside of the orange lines, right? So they're on the same side, but in the interior. So our answer would be angle 3 and 5 are same side interior angles. And also angle 4 and 6. So those are your 2 different pairs. Now, one thing we're going to see here is if I was to fill this in, like let's say this was 100 degrees, angle 1 and 4 are vertical angles, so this would also be 100. Same thing with the angle 2 and 4. Those are a supplementary or a linear pair like we just learned, so this would be 80 and 80. What this says is same side interior angles are supplementary. So that means that 4 and 6 are actually going to add up to 180. So this is 80. This would be 100. And so really what happens is the same pattern for that top 4 really got repeated for the bottom 4. So when we talk about these properties, just remember you only have really 2 angle values, distinct angle values, and they're just getting repeated. So in this case, you could see 3 and 5, they're supplementary, but it also kind of, we were able to find every other piece here. So again, same side interior angles are going to add up to 180. The second definition we have, and again, it's in the name, are talking about alternate interior angles. So alternate interior angles, if we look at what that says, so we have our transversal. We're looking at, again, our interior angles. So that would be 3, 4, 5, and 6. And then I'm going to trace my parallel lines here. And so we're looking at angles that are on the interior, but also alternate. So that means opposite sides. And again, we're not using this for vertical angles or linear pairs. So these are ones that are formed with both parallel lines. So angles on the inside that are on different sides would be like 3 and 6 and 5 and 4. And what you're going to see with this is basically they're going to be congruent to each other, just for that same reason we saw a moment ago. So if this was, let's say, 70 degrees, angle 6 would be 70 degrees. And then this would be 110, 110. Okay? So alternate interior angles are going to be congruent or equal to each other. The next definition is going to be corresponding. So again, if I was to trace this out, corresponding are basically angles that occupy the same position, right? So they're on the same side of the transversal. And so like, for example, if I think of these almost like two different sets, angle 1 is in the upper left, angle 5 is in the upper left, those would be corresponding to each other. They're occupying that same position. Same thing with 2 and 6. And then we have our vertical angles. And so we also have this one, we have a couple pairs of corresponding though. We can name 3 and 7 and 4 and 8. All right. One thing we're going to see is corresponding angles are congruent. So if this was, let's say, 120 degrees, angle 5 would also be 120. So we're going to find that corresponding angles are congruent. The last definition we're going to have are alternate exterior angles. So same thing, I'm going to highlight my parallel lines and my transversal. Exterior means on the outside of the two lines, so that would be 7, 8, 1, and 2. And we're looking for angles that are alternating, so they're on opposite sides of the transversal, but on the outside. So like this would be like 1 and 8 and 2 and 7. So we're going to find that if lines are parallel, the alternate exterior angles are going to be the same. So if this is, let's say, 30 degrees, angle 2, angle 7 is also 30 degrees. For topic number 2, we're going to be looking at solving missing angles when we are only where we have parallel lines and a transversal, and we're having to identify a relationship to set up the equation. So when we look at this, an easy way to set this problem up, we have our parallel lines. We know we're going to have our vertical angles, and we also know the same angles are going to get repeated, right? So we have like our corresponding angles will be the same. I know that the remaining angles are going to be supplementary to the first angle I marked. And then we're just going to see what relationship we see here. So I have the 70 degrees, and I have the x plus 73. Those are actually going to be corresponding angles. And corresponding angles are going to be congruent, but I could also see just how I marked it. I marked them the same, so I know I can set them equal. So I have here 70 is going to equal x plus 73. We're going to subtract. I get -3, which I'm not allowed to have for an angle measurement, but I can definitely have for a value if I need to, because if I substitute it in, I'll get a positive angle. And if I wanted to find what the value was, I could substitute it in, but I also knew already it was going to be 70 degrees because they're the same. Same idea for the second example. So if I go ahead and mark my picture up, I have my vertical angles, the matching pair, and then I know whatever is not marked is going to be supplementary. And so when I look at my two angles that they gave us 120 and 5x plus 15. Those are going to be same side interior angles because they're on the same side but both on the inside. And so we have here 120, plus 5x plus 15 equals 180. So they're going to add up to 180 degrees. And then from there, we're just going to go ahead and combine like terms and solve. So 5x plus 135 equals 180. 5x equals, what was that, 1, what was that, 35 or 45, and then we're going to divide by 5. So we get our value of x to be 9. If I wanted to find what this angle was, I could substitute it in, or I could even just subtract, and I'll get that to be 60 degrees. The last two problems are essentially the same, kind of the same thing. So if I mark my diagram, right, if they're marked the same, I know I'm setting them equal. And essentially, if they're marked different, I know I'm adding them to 180. These end up being alternate interior angles. And I'm just going to set them equal. If we were to go through and solve it, the solving is kind of the same thing we've been doing. You would get your x value to be 5. And then if I substitute it back in, so put 5 in for x, you would get this to be 120. And then for the last problem, same thing. If I was to mark up my diagram, I can see that these are same side interior, so I'm going to add them up to 180. And then just combine like terms and solve. When we solve it out, we're going to get our x value to be -6. And then if the question is what is the angle, you just substitute it back in. And we would get that angle to be 115. If you have questions, make sure you are trying the U-Try problems and then asking for help during class, signing up for T-Bolt time, or getting help in the center.